All right. You're going to be responsible for the side names. You are responsible for these. All right. Three-sided figure, we already know. We spent 2 darn units on that, right? That's a triangle. Four sides, that's what we're about to dive into, this whole unit, quadrilateral. Now, some people may say rectangle, square, trapezoid. Those are all types of quadrilaterals. All right? Any four-sided figure can safely be called a quadrilateral. All right, time for you to show off. Polygon has 5 sides. It's called a pentagon. Let's show off, guys. Let's go. Pentagon. It's got 6 sides. Hexagon. Uh-oh, here's one we may not know, huh? 7 sides. Septagon, yes. And also I will also write down the other name for it. It could be called a septagon, or anybody know the other name, 7 sides? Heptagon. Heptagon. Either one acceptable. 8, I will not accept stop sign, but I will accept octagon. Yeah. My personal favorite, 9. Oh, stumped them. Stumped the kids, huh? Nobody for 9? Nonagon. Na-na-na-na. Nonagon. 9-sided figures, a nonagon. Anybody for 10? Decagon. Yeah, decagon. Like decade, 10 years, decagon. Ooh, 12. Okay, first I should mention you are not responsible for 11, but anybody know 11? Onagon. Onagon, but we're not going to deal with 11-sided figures. But we will deal with 12. Dodecagon. Dodecagon. And then I skip all the way to 20. I don't even know what that is, nor do I care, and I don't want you to care either. But anything over 12 now, any sides over 12, we're going to take the easy way out, and we're just going to go, like in this case, 20. 20 gone. How about that? That's clever, huh? 20 gone. So anything above 12, we could just say the number of sides gone. So I have n here. If that's bigger than 12, we're just going to say it's an n gone. All right, whatever the number of sides is. All right, so yes, responsible for all those names. A couple vocabulary terms. You guys probably are familiar with this, a diagonal. And every time I ask kids, what's a diagonal? Oh, you connect the corners. True, true. If I'm dealing with a quadrilateral, yeah, I'll connect the corners. But you can also have a diagonal in any of these figures up here. So draw yourself your best ability. I won't be critical of you. Draw yourself a pentagon right now. Draw yourself a pentagon next to diagonal. You can have diagonals in any figures as long as you connect one vertice to a non-consecutive vertice. That's a diagonal right there. Okay, it's don't think corner to corner anymore. Yeah, that's probably true in a quadrilateral, but you connect a vertice with a non-consecutive vertice. That is a diagonal, everyone. That is a diagonal. And every year somebody raises their hand. Well, what happens if you connect 2 consecutive vertices? It's called a side. It's called the side. Okay, it's called the side, not a diagonal. So all good on a diagonal. There are 2 types of polygons. 2 types. One you have been familiar with your entire life. You just probably never had a name for it. That's a convex. All right, a convex polygon where all the diagonals are inside, and that's what you dealt with all your mathematical career. Every single diagonal is inside, inside, inside the polygon. All right, so you just never had a name for it, but all your polygons you've dealt with in math have been convex. And I'm going to introduce a new type right now that probably you've never been aware of. Which is concave, a concave polygon. Here you go. Here's a concave polygon. That's not a polygon, that's an arrow. I hate to break it to you. Ready? 1, 2, 3, 4, 5, 6. That's a septagon. It's got 7 sides. Now, why is this concave and not convex? Does everyone see a diagonal I could draw in on the outside? Can you draw a diagonal? Yeah, absolutely. As long as you can draw one diagonal on the outside, it's concave. As long as there's one on the outside that can be drawn, it's still a septagon. You might call it an arrow, but it's still a septagon. But it's a concave septagon. All right, all good on the differences now. So now we can actually talk. Here's what I want to do right now. I'll give you any of these figures, and you'll be able to tell me how many degrees are inside it. Okay, how many degrees are inside? I think we already know one of them, right? Triangle, how many degrees inside that bad boy? 180. Anybody know quadrilateral? Anybody know that one? If not, it's not a big, we're going to find out. All right, so the only one you know is triangle, 180 degrees. Now you're about to figure out real quick how many degrees are in all of these. And of course, like usual, I'm not going to give that to you. You're going to investigate it in your group by filling out this chart. We're going to look at 5 figures right now. Figure number 1, the triangle, which we know has 3 sides. Then we're going to look at the quadrilateral, which we know has 4 sides. Then we'll take a look at the pentagon, which we just learned has 5 sides. We'll go to hexagon next, which we know has 6 sides. And then we'll finish with the octagon, which has 8 sides. And we are going to try to figure out how in the world do we figure out what all the angles add up to inside. So let me show you how to fill out this chart, and then you're going to finish the chart in your groups. Let's start with triangle. Let's start with the triangle. Notice the next column says number of triangles. Well, how many do I have here? Just 1. Yep. And you guys know, you already told me from the last 2 units, what's the sum of the interior angles? 180. All right, so we're good there. All right, next up, a quadrilateral. This is what I mean by number of triangles. You have to start at 1 vertice and stay there and see how many diagonals you can draw in from that vertice only. All right, so start at 1 vertice and stay there. How many diagonals can I draw in a quadrilateral? From this vertice only. That's it, right? Like, where's the other one? I got to come from this one, right? It's got to come from the same vertice. That's what I mean. So how many triangles did I just form? 2. Each triangle has how many degrees? 180, 180. Add it up. Now how many degrees in every quadrilateral? You just figured it out. It's 360. Every quadrilateral is 360 degrees. So that's what I want you to do now for the pentagon, hexagon, and octagon. All right, if you want to draw it out, draw it out. Start at 1 vertice and see how many diagonals you can draw in. That'll give you the number of triangles. Multiply it by 180, that'll give you the sum. All right, so go ahead. See if you can fill in the rest of the chart here with your group. Make sure you guys all match before you tell me your answers. Remember, when you draw your diagonals in, you can only go from 1 and then, yeah, You guys will probably pick up on a pattern by the time you go to octagon. Just do a quick comparison in your group when you're done. Looks like some of you guys are picking up on the pattern. If you know the number of sides, you'll know the number of triangles without drawing it. Quick comparison in your group before I call on some people here.
Oh, thank you.
All right, let's fill in the chart here together, make sure it's all correct, because there is a definite pattern here. Let's start with pentagon with somebody with the pentagon. Here we go. Pentagon. Izzy, how many triangles did it form? 3. Yes, it did. So in a pentagon, how many degrees? 540 degrees in every pentagon. Perfect. Hexagon. Let's go hexagon now. How many triangles did it form? Halo, how many triangles? Hexagon. 4 triangles, yep. So times 180, how many degrees in every hexagon? 720, perfect, thank you. And finally, the octagon. How many triangles did the octagon form there, Lennon? 6. How many degrees in every octagon? 1,080 degrees, yeah. See a pattern at all? All right, let me test it then for you. Let's say now I have a 16-gon, which tells us that's 16 sides. Can you predict the number of, well, we know number of sides, 16. Can you predict the number of triangles? Based on all our work here, how many triangles are you predicting that a 16-gon will have there? 16-gon. Juliana? 12? What was the pattern here? I had 6 sides, 4 triangles, 8 sides, 6 triangles, 4 sides, 2 triangles. It's always, so what are you going to have here?
14.
14. Why 14? Because you're going to explain the rule to me now.
16 minus 2.
It's always 2 less, right? The number of triangles is always 2 less the sides. And then what do I do with that 14 to find the total degrees? Go ahead and multiply by 180. That's a big number, 2,000. Yep. So now can we find how many degrees are in any polygon I give you now? Yep. I take the number of sides and do what? Let's talk about take it number of sides and subtract 2 and then take that and multiply it by 180. All right, let's make this official now. I don't care that you know that this is called the polygon angle sum theorem. I just want you to be able to find it. All right, so the sum of the interior, these are all the angles on the inside, the sum of the interior angles of any polygon equals let's make this official. What do you do to the number of sides again? It's -2. So the number of sides will always be given to us. So I'm going to call that n. N is the number of sides. You subtract 2 to figure out how many triangles, and then you do what with that? Multiply it by 180. There's your formula that you guys came up with. Take the number of sides, subtract 2, and just make a little note for yourself that n is number of sides. Okay? That's interior angles only. Interior only. All right, let's try to use it now. Find the sum of the interior angles of a 100-sided figure. 100-sided figure. Juliana, back to you. Let's use our formula now. 180. And what's my n value now to plug in? 100 sides. And then I'm going to subtract 2. And there it is. And let me know, Juliana, when you have it.
17,000.
Woo! 17,000. Woo. It's a lot of degrees. It's a lot of angles, too. 100 angles. Questions? All right, one more here on the interior before we head on the outside. Find the missing angle. Well, it would be nice to know what all those add up to. Can somebody first tell me what this figure is? Name it. Count the number of sides and name it. Count the number of sides and name it. What is this polygon called there based on the number of sides? Maddie? Pentagon, good job. So we can either look, you guys can look back at the chart or do it again. 180 times 5 minus 2. A pentagon has 450 degrees, 540 degrees. You know 4 out of the 5 angles. Go ahead, solve for x. I know they all add up to 540 now. And when you have x, let me know. What is that missing angle that makes it add to 540? Take your time. Izzy, when you're ready. $1.03. Good job. Excellent. All right. Any questions on the inside angles, the interior, because we're going to go on the outside now? Anything? All right. Well, there was definitely a pattern that we saw for the interior angles, and there will be a definite pattern we're going to see for the exterior. But like usual, you guys are going to find that for me. So I'm going to split you guys up into groups right now. This is going to be group 1 right here. You guys are going to be responsible for that figure when I tell you what to do. Group 2 right here, you're going to be responsible for that quadrilateral. Guys over there, group 3, you're going to be responsible for the triangle. Here's what I want your group to do with your figure. Go to every interior angle and find the exterior. How are they related? How are you going to find the exterior? What do you think? The interior and exterior should add up to what? $1.80, all right? So group 1, you're going to find all 5 exterior angles. And then after you're done, I want you to add them up for me. That's what I really want is add them up. Group 2, you're going to find 4 exterior angles. All right, you're going to find 4 exterior angles. Add them up, and I want to know what they add up to. And then group 3, you got the easy job. You're only finding 3 exterior angles, but still I want to know what they all add up to at the end. So go ahead, make sure you compare at the end with your group. I really want to know what they add up to. I'm not concerned about each exterior angle. I want to know what they add up to. Take a peek around. Everyone in your groups get the same sum of their exterior angles. Group 1. What did all your exterior angles add up to? 360? Yes, indeed. They all added up to 360. Group 2. What did yours add up to? 360 again. Hey, group 3. Every single group, no matter how many sides it had, ended up with all the exterior angles adding up to 360. That's an easy pattern to figure out, huh? Doesn't matter the number of sides. No, it does not. It does not matter the number of sides. The sum of the exterior angles of any polygon. I have no formula for you here. What am I just going to set it equal to? That's it. Doesn't matter. Pentagon, octagon, 50gon, does not matter. The sum of the exterior angles will always equal 360, no matter the number of sides. Always. No fancy formula. Questions on that before I go on this first example? All right. What's the sum of the exterior angles if I have a 36-sided figure? "36 sides. What are all the exterior angles add up to?" Keating?
360.
Thank you for not just picking up your calculator and pressing buttons. It's done, guys, right? It's done. Exterior angles add up to 360. I don't care how many. I put 360 sides, 3,600 sides. It doesn't matter. All right, we don't need to do many examples of that. Last thing I want to do with you. We have been talking about all the angles added up now. I want to talk about one single angle now. How do I find a single angle inside or outside? And before we do that, I have one last vocabulary term, which is a regular polygon, which most of the time we will be dealing with. If you know, a polygon is a regular hexagon, regular octagon, a regular pentagon. It's got a couple properties to it. If you know it's regular, I guarantee if somebody was just to guess what's true about a regular polygon, you'd be right. Regular polygon. Anybody want to guess? Because you're probably going to be right. If you hear a polygon's regular, take a guess. Just take a guess. You'll probably be right. Nothing. Nobody wants to take a shot. Sure, Taylor. What do you think?
360.
What's three? Well, yes, all the angles add to 360. That's not going to change.
Exterior, one exterior and one interior.
Oh, I'm just looking at regular polygon here. What do you think if a polygon is right? Here you go. I should probably throw up an example. If I tell you this pentagon is regular, what do you think you know about it? Without even me telling you what regular means yet. This is a regular pentagon. What do you think I know about it? Go ahead.
It has 5 sides.
It does. Well, any pentagon's going to have 5 sides, but what about those 5 sides? If it's regular. Done. All 5 sides are equal. In a regular polygon, all sides congruent. All right, all sides congruent. More. Build off it. All the sides, yeah? Okay, yeah, let's get specific now because we have 2 types of angles, right? All interior angles congruent. Okay, in a regular polygon, all the interior angles. So take a look here. All of those are going to be equal. So all of those are equal. What's my last one here? All the exteriors have to be equal. Yep. There you go. That's a regular polygon. All the interior angles are equal, and so are the exteriors. All right, let's dive into this about finding one angle only. Number 4, you got a regular polygon, so that tells me everything's congruent. It's got 20 sides, all right, 20-sided figure. One exterior and one interior angle. What are they going to be? One exterior and one interior. I'm going to start with the exterior. That's always easiest. I think how to find one exterior angle. First thing, I'm going to ask somebody, what do they all add up to? All those 20 exterior angles, what do they all add up to, Hayden? 360. Yeah, they all add up to 360. And remember, because it's regular, all of them are the same. So what do I do with the 360 and the 20? Divide it. 360 divided by 20. That'll give you one exterior angle. So in this 20-sided figure, one exterior angle will be 18 degrees. All right, ready for the interior now. Exterior, again, I always start with because I know they add up to 360. I don't know what the interior angles add up to, but you have a formula that can find it, right? Everyone's got a formula that can find it. What's the formula I gave you at the beginning, or you guys found at the beginning of class today, to figure out what all the interior angles add up to? They all add up to, what's that formula again, Taylor?
540.
Whoa.
You want the equation, sorry.
Yeah, 540s for a pentagon, right? This has 20 sides.
Oh, yeah, sorry.
So what's the formula to find the number of degrees?
It would be 20 minus 2 times 180.
You got it. So we'll find that. And what is, I don't know, anybody got that? 3,240. That's the total. And now I divide that by 20. And that should give me 162 degrees for the one interior angle. You guys are above average, they tell me. Could I have gotten 162 a different way without having to find the total, 3,240? Could I have gotten there a little quicker knowing the exterior already? I already know the exterior. Could I have gotten to the interior a little quicker and without finding the 3,240? Guys are shaking your head. How many?
180 minus 18.
Yeah, remember, interior and exterior, add to 180. They're supplementary. So I could have also done 180 minus 18, and that also would have gotten me 162. Good job. And I don't care how you do it. I don't care how you do it. All right, a little different now on 5. Now give me the number of sides. How many sides does a figure have if I know one exterior is 120? And I don't want you to guess and check. Like, oh, let's try 5. Let's try 6. Let's try 7. I don't have time for that business. One exterior is 120, and they're all the same. How many sides does it have? Exterior, what do they all add up to again? I'm dealing with an exterior, so what do they all add up to again here? T?
360.
So, all right, so number of sides. I can take 360 because they all add them up, and each of them's 120. So what can I do with the 360 and 120 to figure out how many sides do I have? 360 divided by 120. This is a 3-sided figure. Oh, my heart melts. It is a triangle. Can we get more detail? If it's a regular polygon, equilateral triangle. There we go. That's what I'm looking for. Details. All right, 6. How many sides? All right, now I'm changing it up on you. I won't give you an exterior. Now I'm telling you one interior is 160. One interior is $160. How many sides? This gets a little more complicated. But, whoa. Interior 60. Let me help you out. Could all of you find what an exterior angle is equal to? And I'll tell you why I want to do that. If you know the interior is 160, how can you find the exterior right next to it? Right next to it. Zoe? There we go. So the exterior in this problem is 20. Why does that help us? Now it turns into problem number 5, doesn't it? What do all the exteriors add up to? Look, there you go. So if you want to find the sides again, I take 360, and just like I did in number 5, divide it by one of the exteriors, 20. So if you can deal with an exterior, guys, please deal with an exterior angle. Because you know they all add up to 360. So this is 18 gone. And 18 gone there. All good. And we got one more here. The sum of the interior angles is 2,880. How many sides does it have? No guess and check. No trial and error. What is this number? I know it's 2,880. What is it representing in the problem again? 2,880 are the what? Number of degrees in Lennon, what is that? The number of degrees in the polygon. Where in the polygon? Inside, right? Inside. That's the number of degrees inside the polygon. I believe you guys in your groups came up with the formula for that earlier today, didn't you? The sum of the interior angles. What was that formula again? That was for the sum of the interior angles. Jesse?
180 times the sides minus 2.
And now we know what it's equal to. 2,880. Are you comfortable solving that? Algebra 1 kids here? Yeah, we're comfortable solving that. You can, how many of you are going to want to distribute? Go ahead. Anybody want to do it a different way other than distributing? Anybody want to divide 180? You can do that too. Go ahead. You do the way you want to do it. And I'll call on somebody for the last one here. See how many sides it has. I don't care if you distribute or divide by 180 first. Your call. When you're ready, solve that thing first. When you're ready, Juliana, when you're ready. 18 sides. Yep. Please also remember when you're doing a problem like this, you get a decimal, something went wrong. I can't have 18.2 sides. All right, I got to have whole number sides. So just keep that in mind. All right, textbook problems are down at the bottom. Let's get rolling.